Everyone wants to measure developer productivity, especially once you hit 100 engineers. Most teams default to tracking what's easy: number of commits, lines change, or number of PRs someone's open. And sure, those things are great and can tell you when something's wrong, i.e., if someone hasn't shipped a PR in a month, that's probably a negative signal. But those metrics tell you almost nothing about what great engineering performance looks like. I've learned from leading teams across startups to public companies, activity metrics don't tell you about developer productivity. They just tell you who's keeping busy. And I get it. Even talking about developer productivity can feel a little bit iffy. It's gotten a bad rap because people try to measure like factory output. The truth is, measuring engineering productivity isn't bad. It's that most teams measure motion instead of progress. They count activity, not improvements. And every organization's version of progress looks a little bit different. After a decade of managing teams at scale, I think there are three core signals that have been most reliable for me. One, time to first PR. Second, median to merge. And third, the PR composition. For each metric, I'll break down where it actually measures, share where I've seen it play out, and walk through the strategies that have worked for me so you can adopt them for your own team. Let's start with the first one, time to first PR. How long does it take for a new engineer to ship their first piece of code? This isn't about the size of change. It can be something small, a small bug fix, a config, or tweaking a small component. What matters is that gets them through the entire flow: the setup, the editing and coding, the testing, the review process, and merging and deploy. The time to first PR really is a proxy for your onboarding quality, your documentation, setup, and code access. At a small startup, this doesn't affect developer productivity much, but once you've hit dozens or hundreds of engineers, every bit of friction in the onboarding flow compounds, not just for new engineers, but for senior engineers who have to be pulled in to unblock them. It's one of these invisible taxes that quietly drags down the developer productivity across your engineering org, and you get to see this hands-on when engineers onboard. In my first job out of college at a startup, I was told you'll be merging something at the end of the day. It sounded aggressive, it was challenging, but it wasn't about pushing significant work on that day one. It was about understanding that process end to end. By the end of day one, I knew how to set up everything, how to make changes, and how to get it working in my IDE, how to run tests, how to get the review from your teammates or relevant team members, and how the CI process worked, and then finally how deploy actually worked as well. It built confidence fast because I now understood how everything fit together. And that's the real value of this metric. If new engineers can ship even the smallest PR in their first day, it means that your onboarding tools and process makes sense. Everything's working together as they should be. So how do you actually improve the time to first merge? First, you have to really think about how to automate that setup. If the environment setup or access request takes a long time, you need to automate them. Using setup scripts, use containerization, or think about internal templates to get people onto their laptop and get the code running fast. Second, how do you create that simple task, right? Keep a backlog of small, low stakes, easy issues, small fixes or doc updates that someone can kind of tackle for their first PR. The goal isn't to get a lot of immense value from this change, but it's really to get familiar with the entire development cycle end to end. Third is to make ownership and process clear. New hires should know who's reviewing your changes, know how to get feedback from your teammates, and where all your code standards live. The clarity reduces the back and forth and builds confidence early in their tenure in your company. Once the onboarding is smooth, the next bottleneck for developer productivity isn't setup. It's just how efficiently code moves through review to merge. The second metric that actually matters is the median time to merge. How long does it take for a pull request to go from open to merge? At scale, this number becomes one of the clearest indicators of developer experience. It's one of the biggest levers to really increase productivity within your engineering org. Because at hundreds of engineers, your bottleneck isn't about writing code anymore. It's about how quickly code moves through your system. When merging takes too long, engineers lose context, lose momentum, and become demoralized. They start juggling multiple branches at the same time, waiting on review, waiting on flaky tests, or just the CI pipeline to finish. This is not a productivity problem. It's a feedback loop problem. It usually breaks down in two places: the code review and the continuous integration. At Rippling, we ran into a challenge that almost every growing engineering org faces. Merge times started to stretch to days, not because people were slow, but because of unclear ownership. PRs would take a lot of time to figure out who should be the right person to review and who had the most context. Because the engineering team was growing so quickly, it became harder to track who knew the most about this piece of code, and ownership started to become uncertain and unclear. How we fix this is really start to codify who owns what piece of code and really make that ownership very precise and codify all of that into GitHub Teams or through documentation. This alone drastically cut our review time when people knew who to look for to get feedback on their code. If I were running a team like that today, I would also layer in AI assisted review to help reviewers get there faster, not to replace human judgment. Every PR should start from a very strong baseline. So even when human reviewers add comments later, you end up with fewer review cycles back and forth because most of the issues have been addressed and surfaced upfront. The other big driver of merge time is continuous integration. Your test and build pipelines taking a long time. As teams scale, CI times almost always get slower because new services, new dependencies, and new test suites adds weight to your CI system. The natural trade-off for growing fast is more checks and more safety, but they also mean more waiting. When CI drags, feedback becomes too slow. You push a change, wait for tests, and by the time they finish, the main branch has already moved ahead, forcing another round of rebase and another round of validation. At Twitter, we tackled this by using a multi-tier CI system. So for individual pull requests, we actually only ever ran a subset of the tests and checks at all time. And we were able to help reduce down the time it took to actually run the CI for any individual pull request. And later on, after a bunch of pull requests have been merged into main, we ran a continuous integration test that actually ran the entire suite of tests within Twitter as a whole. And we were able to validate that this batch of changes were all valid and were all good. And if tests ever failed, then we can go back and figure out which one of the individual changes broke the test. But this allowed us to really break it down to running only what mattered within that first initial dev loop, and then really trying to retroactively fix if anything came up. But this really helped individual engineers move a lot quicker. At Rippling, we took a different approach by creating minimum viable tests. No single test can take longer than 10 minutes. This forced engineers to really keep tests efficient and well scoped. Optimizing CI really was about optimizing learning. The faster your system taught your engineers what was broken, the faster they can build things right. Once your merge process is fast and predictable, the next question isn't how fast the code gets shipped, but it's also what kind of code are you shipping? Some PR fixes, other build new features. If you don't track the mix, you don't know whether your team's productivity is fueling progress or maintenance. This brings us to our third metric, PR composition, the ratio of your PRs that are bug fixes or new features. When I joined Rippling, we were spending most of our time fixing bugs. It wasn't clear why we're stuck in this loop or how to get out of it. To get out of it, we actually needed to bend the support curve and first start to track our PR composition. Until then, all we knew that the team was busy, and we don't know busy with what. Once we start tagging every PR as features, fixes, or refactors, we could start to finally see where our time was going. The visibility changed everything, and it turned gut feeling into data. We could start to set measurable goals, like reducing the percentage of bug fix PRs by X amount over the next quarter. Over time, the patterns became clear. When the bug fix ratio spiked, it meant that instability or tech debt was occurring. When feature work rose, it showed the foundation was healthy and stable. The shift in ratio was really what helped us bend the support curve. The line of incoming bugs flattened even as usage grew. To actually improve this metric, you have to go deeper than fix fewer bugs. Set aside time to look for where bugs are coming from, and then address those root causes directly. Implementing this is simple, but tedious. That's why a lot of teams skip it. Tagging PRs as a feature, bug, or refactor sounds like busy work, and people don't often see the immediate payoff. But once you have a few weeks of data, the signal is obvious. You start to see patterns fast, And those insights help you direct effort and rebalance priority and advocate for resources you actually need. If you want to take it further, you can use tools like Propel Code to be able to auto-classify PRs based on title, diff, and linked issues for real-time visibility. In the end, PR composition helps you see whether your team is spending energy maintaining the past or building the future. And now there's one more thing I found that ties all of this together, and it's not a metric itself. It's actually staying hands-on. And to be clear, it doesn't mean to jump back into every pull request and writing feature scan or shadowing your team's work. It's not about control or even nostalgia for coding. It means staying close enough to the code to understand how they've structured their code and what a typical task really takes. Practically, this looks like keeping the code cloned locally, occasionally exploring it using your IDE, and getting full deep understanding of the architecture and key components, skimming through the key docs, looking at design review on a continuous basis, even when you're not involved in it. It's not about writing code, it's about keeping context. The level of context changes how you lead. You make sharper calls about priority, timeline, and scope. Your feedback lands better because it's grounded in the reality of the work, not filtered through dashboards or second-hand accounts. The real foundation of developer productivity is not just measuring how fast engineers move, but understanding the environment they move through and designing it to help them do their best work. When you pull these three things together, time to first PR, median time to merge, and PR composition, you get a real picture of developer productivity. Fast onboarding builds confidence. Fast merges keep the flow. Balanced composition keeps progress compounding. And staying technically hands-on ties it all together. That's what truly drives developer productivity at scale. Not metrics or dashboards, but systems that help your team move with clarity and confidence. We'll keep breaking down more lessons from building and scaling engineering teams. And if that's something you care about, subscribe so you don't miss what's next.